Hi, everybody. So in class on Thursday, we stopped at this slide, and I told you that I would make a video for the last couple of slides that we didn't get a chance to do, which should help you work on your homework, which is due at 1:30 tomorrow on Friday. So we were working with model of COVID cases, confirmed COVID cases in California in terms of on the vertical axis. So that was our output, and the input, we're thinking of the number of days since January 26th. So let's take a look at how we can read and explain what's going on with this graph. So when we are describing one point on the graph, we do it with an ordered pair of two numbers. So we have two numbers that we're gonna include here. The first number is always going to be the input, the value of the input, and then followed by the second, which is the value of the output. So we have input is T, output is C. And we write this in between two parentheses. So parentheses means that we're indicating the location of the coordinate of a point on a graph. So in particular, at this point marked in red, we can see that T is equal to 100 by reading the value off of the horizontal axis where the input is. And then on the vertical axis, we can approximate what the value of the output is. So over here, we can see it should be something close to 50,000. So the output value, again, we read off of the vertical axis. And then altogether, we would write this point as the T value is 100, so that goes first. Then the value for C was about 50,000, and that comes second over here. So we have parentheses, one value, the first value indicates the input, which you might think of as like the X coordinate, the coordinate on the horizontal axis. And the second number that corresponds to the output, which is like the Y value, which we read on the vertical axis. And so if we want to then make sense out of this, let me clear this out of the way, then one thing that we could say is, if I'm reading this point and the question is, let's make sense out of what this point tells us, in a very dry sense, we could say when the input is 100, the output is 58,456. This is not where I would like you to end. So the idea is we would like to take this graph and the points on this graph and be able to explain in very practical, clear terms what information this is telling me in this context of COVID-19 cases. So rather than say when the input is 100, this tells us it's 100 days after January 26th. And rather than say the output is 58,456, we should explain what the output is. We should explain the total number of confirmed COVID-19 cases is 58,456. So one way that we could write that out in a sentence would be 100 days after January 26th, there were a total of 58,456 confirmed COVID-19 cases in California. So on your homework, you have some questions that are going to ask you to interpret a point on a graph. And when you interpret that, you don't want to use this dry, mathy language over here, but I'm hoping and expecting that you all can explain what this means in very, very practical terms that make sense to anybody walking down the street. So different ways that we can represent these models. Sometimes we'll be working with models graphically. Sometimes we'll be working with models where we've got a table of data, in which case Excel might be a useful tool. We can represent models verbally, explaining in words what's going on, such as saying the confirmed cases of COVID-19 in California are increasing at a faster and faster rate. That is actually a model that is representing a realistic situation. And when possible, we can represent some models using formulas, and then we can make some predictions and quantify the uncertainty in those predictions. That's what's going to come on class on Friday. So in section 1.1, they introduced this idea of a function. And so a function is just a rule. You can think of it as a machine, and input goes X. So we have input goes into the washing machine. And when our variables are not representing anything concrete, we typically use X as the variable for the input. So the input goes into the function, and then out comes the output. And we typically, the default variable to use for the output is Y. In our case, we're oftentimes going to be working with variables that are representing actual real quantities, and we'll use letters that are descriptive of those quantities. But in absence of any application, we typically use X for the input and Y for the output. And we explain that Y is a function of X using some nice, concise mathematical notation. So if we want to write out more concisely using notation this idea that Y is a function of X, that the value of Y is affected by the value of X, then we can simply translate, well, Y is Y. Is, we translate as an equal sign in mathematics. Instead of writing out the entire word function, we shorthand that with the letter F. And then we have parentheses. So I have one parenthesis here, I close the parenthesis in here, and what we plug in, the variable that's being plugged into the function, the input variable, goes inside the parentheses. So we usually don't write those big spaces. We would just write Y equals F of X. So in kind of words, I would say we would read this as Y equals F of X. And what this is telling us is that Y is, again, is the equal sign, a function, and then inside these parentheses goes the input variable, which in this case is X. So although this notation sometimes might seem annoying and unnecessary, the real point is it gives us a very nice way of writing out more complicated statements very, very concisely. And we'll take a look at that on the next couple slides. Okay, so if, for example, I am told that the quantity supplied Q is a function of the price P, how can I write this using function notation? Well, the key here that we want to pay attention to is we have Q is a function of. So this, the first thing that comes, the first variable here is Q. That tells me that Q is the output. So is a function of, you can almost translate as, oops, I don't want that. So is a function of means depends on. So here what we're saying is the quantity Q depends on the price P, which is equivalent to saying Q is a function of P. So one way to think about this is to just translate each word in this sentence. Q is an equal sign, function of gives us F with the open parentheses, and then the last bit is what is the input variable, and that we can see over here is price P. So inside here goes the P. So one way you can write this out would be just translate each symbol, word, in terms of its mathematical notation. And for a problem like this, there would be nothing else to explain other than here I've written Q as a function of price P much more concisely. If you're having trouble with these, what is really the critical thing here is to identify what are the variables and which is the input and which is the output. So we've got a Q and a P. And whenever you say Q is a function of, that means Q depends on something else. That means Q is the output. And P, therefore, is the input. So Q depends on P. So Q is the output, P is the input. And so then once you identify what the output and the inputs are, the general form of writing out this notation is to say the output, which in this case is Q, is a function of the input, which is P. So I think this step of first identifying what is the input, what is the output is going to be really useful for a lot of the things that we're doing this semester. So it's good to get in that habit now. Okay, so here's the very last thing I want to do. And I'm going to just tell you that I will make another video that works through some of the solutions in the textbook. So if you want some more help and the videos are useful, I'll put a couple of additional videos up on Canvas that work out some examples that are similar to your homework. So these are certainly similar to your homework. So in this case, we've got V in thousands of dollars is a function of age of the car. So remember how this goes. Whatever comes before the function part of the sentence, that's the output. And whatever V depends on whatever variable V is a function of, that is the input. And so if we were to say that V is a function of the age of the car, then what we would write is that V is a function of the age of the car, just like we had on the previous slide. And so now this helps me identify which value corresponds to which number. So the thing that is inside the function, that's A. So this tells me the car is 0 years old. So in other words, the car is new. V equals 25 means that its value, right, the units of V are thousands of dollars. So this tells me when A is equal to 0, V is equal to 25. In other words, when the car is new, its value is $25,000. So when you're writing out these interpretations on homework, they should be sentences like this, okay, that you could explain to someone walking down the street. There's nothing all that mathy about this statement here. We've taken this mathematical notation, unpacked it, and written it in very practical terms. So that's the goal. Your answers this homework assignment shouldn't be any calculations or formulas to solve, but just explaining what these things are representing. If we want to explain what f of 7 equals 12 means, this means, well, the age of the car is 7. V is 12, so its value is 12,000. So here we could say when the car is 7 years old, its value is $12,000. Okay, so the advantage to this is that it's much more practical and easy to understand. The advantage to the notation is that it's much more concise. It's much easier to write f of 7 is equal to 12 than it is to write out the sentence. But what I hope is for all of us is that we can bounce back and forth between this notation and the practical interpretation. So we're really just learning another language at this point. So here, f of 35 equals 0. This means when a is 35, v is 0. So when the age of the car is 35 years, it's not worth any money. Its value is 0. It's depreciated to no value. So when the car is 35 years old, it is not worth any money. Its value is 0. And then for this very last one, we kind of have partially completed notation. So I don't know what f of 10 is. So we don't know the value of the output. So the output here is not specified, but we still can explain what this object represents. So f of 10 means the input is equal to 0. So if I plug a into this function, f of 10, what comes out of it should be the value of the car when a is equal to 10. So f of 10 we can represent as the value of the car when it is 10 years old. So this should give you a good launching point for the homework problems. And I will put up a separate video of 1 or 2 of the examples, not the ones that are assigned to you, but problems that are similar to the ones that have been assigned to you, just so you can see how I would go about solving those problems.